मैं सर को वीडियो ऑन करिए.
Yeah.
Yes, sir, just unmute your video. We can take a screenshot.
Oh, I see.
Yes, sir. Your video.
I have unmuted.
Video.
As soon as, sir, your video is not coming.
Can I see?
Yes, sir. Yes, sir.
Yeah.
Okay, sir. So thank you.
Can I mute this?
Yes, sir. You can mute.
So we start.
Yes, sir.
So the second talk of this webinar is by Professor R.K. Mishra, retired professor of Barampur University Electronic Science Department, and his talk will be from Shunya to innovation. Shunya is our word, I think. Innovation is their word. So how we can contribute to the world from Shunya, I think Professor Mishra will tell. The Shunya to innovation, rethinking of Bharat's contribution to knowledge system. So Professor Mishra is very, apt in, he has given many webinars on this Indian culture, Indian scientific, development, or our ancestral developments. And he has given a series of talks also after retirement during a few months. Professor Mishra is an expert in the communication, planar antenna, and application of soft computing techniques for the design of planar antenna. In fact, Professor Mishra is a founding member of Department of Electronic Science. I once told that he is really one of a tripod stand. I told you once that a tripod stand is a stable stand that they have developed the department from scratch, from the beginning to this level. Even if we are in a very small place where Barampur is unknown, he could make the people feel that there is Barampur University where this communication research, this antenna research is going on, and he has a good position in his field in India as well as abroad. And he is a very able, scientist. He did got British Commonwealth Fellowship in 99, 2000. He had about 150, more than 150 contributions, research papers in international journals of repute, 2 monograms. He got J.C. Bose Paper Award in 1999, and he got Hariom Ashram. Important that he was awarded the prestigious Samant Chandrasekhar Award by the government of Odisha on engineering technology in 2008. You see, from 8 he got this award. At a very young age, he got this award, even if there are other physicists, industrialists, the electronics people are there, he could get this at his early age. So, and after his retirement, recently he is also very active, and he has been producing more than 10 doctoral PhDs. Besides, he is a very good motivator, and he is a very, positive-minded person to take this small department into new height. It's all credit of him that the Department of Electronic Science could be known throughout India that, and I have, and the department has really grateful to you, sir. And I request you to speak on this topic, this Shunya to innovation, rethinking of Bharat's contribution to knowledge systems. Professor Mishra.
Nothing. Whether I deserve this or not. But anyway, at the beginning, let me promise one thing. There will be no research component in this talk. And as you said, from Shunya to innovation, what this country, this ancient country, has contributed to the mankind. Actually, a large portion of this is taken from one of my previous deliberations, but it will be expanded here. And with that background, let me start. When it comes to Bharatvarsh or India, if you go abroad, outside, mostly in the Western countries, when you discuss with them, they say what is their contribution to the present mankind, present society. And when they ask us about what is our contribution, usually the answer is zero. We contributed zero. Bharatavarsha contributed zero in the number system, and India, which is the new Bharatavarsha after independence, the contribution is zero, which means there is no contribution, no noteworthy contribution in the science. This is what is the perception, and we will now try to see whether this perception that Bharat contributed zero and the present contribution, present India contributed zero, is correct or not. So that is the idea of this presentation or this talk. So there will be no research involved, that much I can assure. So students hopefully will enjoy because there is no research. Okay. So to understand what is the contribution of Bharat, we must know in the ancient traditional system what was the education. In education, what people were learning or what people came to know once they complete their education in the education process, what was being taught or how they were acquiring knowledge. So that we can start with Shruti. Shruti also is known as Veda because people remembered it in the old days by listening it. Listening is called Shruti. So Veda, other name is Shruti. So it starts with Shruti, then goes on to Smriti, which is like a thesis on different branches of studies, and they completely subsert to the Shruti. Shruti is the Veda, is the final authority. Next. Then from Shruti comes the Puranas, the 18 Puranas written by Veda Vyasa. It has a 10-dimensional document, and it encodes history, explaining different events in the past. So it has history, a proportion of it is history, but it is described in the manner of stories. And then from Purana we come to Itihasa. Itihasa is Itihasa. Itihasa means this is how it happened. So it is different from history, but nearest translation to English of Itihasa is history. We have two Itihasas in Bharatverse, Ramayana and Mahabharata. These are the only two Itihasas which have recorded how the events have unfolded, happened in those things. Then comes the Agamans. These are treatises on different technology, epistemology. Also, they describe architecture, geometrical principles for different constructions, etc. Finally, after the Agama comes the Siddhanta. These are established principles for different branches of science, which include astronomy, physics, mathematics, etc. Cosmology. There are in total 18 Siddhantas. So this was the education that people were getting. Complete education in Bharat was this. This constituted the complete education. Now, if you go through this education, what we are learning? Start with Vedas. Let us start with Vedas. So, to start with Vedas, what is there in Vedas? What is relevant to present day science? Electronics is definitely a part of science, so that is also relevant to electronics. So that is the numbers. Mathematics or the numbers are relevant to us. Shroko ekacha, metisascha, me pancha, cha, me sapta, which means this is a shloka in Yajurveda Sri Rudra, Chamaka chapter 18th Anubhav. It says, or it is a prayer to Lord Shiva, which says that kindly bless us with numbers 1, 3, 5, 7, 33, and numbers 4, 8, 12, 16, 48, etc. for prosperity and happiness. Now, if you can see here, there are clearly two distinct sets of numbers 1, 3, 5, 7, etc. and 4, 8, 12, 16. 1, 3, 5, 7 are odd numbers, 4, 8, 12, 16 are even numbers, which means and there people at that time in the Vedic age knew about odd numbers and even numbers. This is the oldest record of odd and even numbers. Recorded. Even and odd numbers recorded in the this is the oldest record. So this is one contribution that has come from Bharat beyond zero. So I am not saying that zero is the contribution, but even and odd numbers they knew. So this was one contribution, dividing the numbers. Then in the Yajurveda Samhita, 17th chapter, the second mantra says Ekadasa Sapa Sahasra up to Prarabdha, which is the numbers 1, 10, 100 up to Prarabdha. So these are the numbers. Now, of course, in the Western you have billion, million, etc. But in the Bharatverse it was Kharab, Brinda, Arbuda, Koti, Prarabdha. This was how the numbers were defined or called. So this is a decimal system that you can see in powers of 10, 1, then 10, 100 in powers of 10. This is coming from the Yajurveda Samhita. So in the Vedic age, people knew about the decimal system. So those were called as watts. Numbers were described in watts, not by numerals. Then in the Agni Puja also you see the powers of 10. O Agni, may the bricks of Yajna, 1, 10, 10 tens, 100, 10 tens is 100, 100, then 10 hundreds is 1000. So this way. So Yajurveda also mentions the powers of 10 in the Agni Puja. Next. So mostly in Yajurveda that is there. Then another very important scripture is Susruta Samhita, which is on medicine, particularly on surgery. In that, there is a verse which says, or I'm not reading the verse, but the verse describes six types of tastes: sweet, pungent, sour, bitter, astringent, and salty. These are the six types of taste that exist. And if you take a combination, so it is the first time or first record of permutation combination. If you take different combinations or permutations, how many tests you will get, how many combinations we will get? 2 to the power 6 minus 1, which is 63. So we can get 63 unique combinations of 6 tests. Now, this is first time where we use permutation combination. Not only that, you can see it is 2 to the power 6, which means we use a binary number. Two types of text. Two. Um, so this is also for the first time. This is another conclusion. Then, if you come beyond the Vedic period to come to Ramayana, in the Ramayana you can see the army quantification of Rama and Ravana. These are in terms of the powers of 10. So we knew about 10 or decimal system. Why I am saying this? Instead of 0, our contribution was mostly to decimal system. That is why I am showing this. How the decimal system was prevalent in different scriptures. So this is in the Judya Kanda, 28 Sarga, from 33 to 43. So these 10 slokas. Next. Same thing in Mahabharata also, it is more precise description of the number of soldiers or the number of army in different categories. Chaturanga Sena, so the four types of Sena: elephants, horsemen, chariots, and foot soldiers. For the Pandavas and Kauravas, this is also described in Mahabharata. The numbers, look at the numbers. So we were knowing the decimal number system till Mahabharata period, definitely. Next. Then, how large was the number that we knew? If you look at that, in the Lalita Vistara, uh, the largest number is 10 to the power 53, which was called Talakshan. And in Anuyoga Dwara Sutra, the largest number is 10 to the power 140. Now we cannot imagine 10 to the power 140 today. Today there is no name for 10 to the power 140, or there is no mention of 10 to the power 140. So it was mentioned in those days. So this is such large numbers people were using for different purposes. What was the purpose? Purpose was basically astronomy. If you look at astronomical objects, the distance is very large, so you require large numbers. So they were using such large numbers in those days. Astronomy was astronomy has really prospered in India. So because of that, this was existing. These large numbers people were using. Now, if we discuss about these numbers, decimal numbers, then we must know what is the number system. When we say decimal number means it has a base which is 10. What is base? Base is, if you want to understand it, the philosophy of base, look at the English alphabets. Simple. We have 26 alphabets. But out of those 26 alphabets, if you take different permutations, combinations, you will get innumerable words. You can generate innumerable words. Base is 26, only 26 alphabets, but that generates innumerable words. That is what is base. So those are the base. 26 alphabets are the base. Similarly, 10 numbers 0 to 9, that is the base. 10 numbers are the base. That is in the decimal system. In the ancient number system, Egyptians used 10 as the base. Babylonian used 60, Mayans used 20, Chinese, ancient Chinese, they used 10. In the present, we use decimal, binary, octal, hexadecimal, etc. Next. Now, when you have this number system, then every number has a value. Each number or each numeral has a value. How to understand what is the value? Suppose we take 20,000 rupees. So its absolute value is 20,000. If it is with a poor farmer, 20,000 is a large amount of money. If I take a shopkeeper, 20,000 is also a large amount of money, but it is less compared to the farmer. Then you come to some corporate employee, it is still a large, but very less compared to the shopkeeper. So this way it goes up. If it comes to the Ambani, 20,000, same absolute value is same. But as the position changes from farmer to the industrialist, top industrialist, its value changes. Also, it has less value. With Ambani, it has less value. If I translate that into the numbers, we developed in the decimal system something called place value system. This is the real contribution, not zero. And so we will see that zero is not the contribution from India or from Bharat. Zero is not the Bharat is not the only contributor to zero, but the only contributor to place value system is definitely Bharat. So if you put three in the ones place, its absolute value is same as positional value. Tenth place absolute value is 3, but positional value is 30. If you keep on increasing it up to 10,000 place, absolute value remains same 3, but positional value is 30,000. So this is the place value system using the decimal, using the zero. We developed the place value system. This is the real contribution in terms of numbers from India. Now, for this and development, we require the numerals. We require the numerals. The in Vedas, Ramayana, Mahabharata that I described or discussed up to now, we do not get any mention of any numeral. The earliest mention of numeral that has been found in Bharat is in something called the Baksali manuscript, because this manuscript was discovered in a village or in a place called Baksali, which is now in Pakistan, and it is written in Sarada script. This manuscript contains the record of zero, oldest record of zero. This describes basically mathematics, mostly arithmetic. This describes the principles of arithmetics. Oldest record of zero is in this manuscript, which is represented by a dot. So this was around 3rd or 4th century, current era. And these are the numerals that we used, 1, 2, 3, 4. The numerals that is used in the Bakshari manuscript in Sarada script is given at the bottom left. If you look at the right hand side, you see the numerals that were used by the Maya civilization. Maya civilization was prevalent in American continent, particularly in South American continent. This was around 2000 BCE to 250 current era. Now, in the Mayan civilization numerals, also you can find there is a zero. So in the Bakshali manuscript, we have a zero, which is not. In the Mayan civilization, which is definitely older than the Bakshali manuscript, we also have a presentation of zero. What is the difference between these two? If you look at this, in the Bakshali manuscript, we have only 10 numerals, 1 to 0 or 0 to 9, only 10 numerals. And using those 10 numerals, we can generate any number. Whereas in the Mayan uh, thing or Mayan numerals, we have many more. So it is not 0 to 9, it is 0 to 9, then 10 has a different numeral, 11 has a different numeral, this way. It goes on increasing. So you have different numerals there, like Roman numerals. We have different numerals. Now, if you look at these two, we had a 0, Maya has a 0. Was there a connection between Bharata and South America? Is it possible? That is the question. Have we got the 0 from the Maya? So to know that, we have to look into the Valmiki Ramayana. So if you can see the website, go to this website and look at the Valmiki Ramayana. There are two slokas here, 440:53 and 440:54. These are the two slokas that is important. I am repeating these two slokas in the next slide. So you can get the Valmiki Ramayana online, read these two slokas, and in the next slide I am repeating this. Next. The first sloka says that a three-headed golden flag shining on the top of a mountain with base at the bottom. Sabedika. Sabedika is base at the bottom. So look at this on the hill, which looks like gold color, and it has a trident, symbol of trident engraved on it, and there is a base to this trident. This is described in Ramayana when Sugriva sends his Banar Sena in the eastern direction. He says that if you go to extreme east, you will find this. He describes different things about what they will find, and one of the thing that is marked is this. Even today we can see this. Next. And he says that this structure was created by celestial god. Indra is celestial god, king of celestial god. So I am writing here Indra. This is created by Indra to mark the eastern direction. So if you go to the east, you will get this. East means from the center of India. In those days, center was considered Ujjain. So from Ujjain, if the Banarsenas were going to the north, south, east, and west. So the Banarsena party or the monkey party is that went to east. To those people, to those army, in that army, Sugriva described what will the east direction, what they will find on different places. Now, whether this is true, look at this. A candelabra of Andes. Andes is the range, mountain range in South America. This you can find in the Andes mountain range even today. Next. This mountain is about 600 to 800 feet tall. The engraving is 2 to 3 feet deep. This engraving you can find from about 12 miles in the sea. Sea is at the bottom of the mountain. Local people say that this is very ancient. They have not engraved it. They do not know who engraved it. And this is described in Ramayana, which means during Ramayana period, people knew about South America. there was somehow some communication, some connection between Bharatvarsh and South America. So it is possible that zero has been transmitted either from South America Mayan civilization to India, or but Mayan civilization is newer compared to Ramayana age. Ramayana is older than Mayan civilization. And Ramayana mentions about zero, it uses 10 to the power 10, 20, etc. So it is possible that zero was transmitted from India to uh, South America to the Maya civilization. They have adopted zero. It is a possibility. I am not saying that this has happened. This, I assume that it is a possibility. This may or may not have happened. Anyway, after that came the era of known Indian scientists. One of the known Indian scientists is Aryabhatta. He has authored 4 books. 3 of them are lost. What is remaining is Aryabhatiya. In the Aryabhatiya, he describes the decimal numbers. Now, what is the main contribution of Aryabhatta? Is he used or coded the numbers, the numerals, into the number form. So Eka is 1, Dasa is 10. So in numeral, he wrote Eka as 1, Dasa as 10. Although Eka, Dasa, Sata, etc. existed before him, he coded them. So in Aryabhatiya, it is coded. So Aryabhatiya is the first scripture which has coded the numerals in decimal form using zero. Therefore, people are confused and they say that Aryabhatta invented zero and invented decimal system, which is incorrect. Zero and decimal system were known to ancient Bharatavarsha, but in the form of numerals, Aryabhatta, the genius, recorded them for the first time. So this is recorded in the second sloka of Ganitapada in Aryabhatta. So this is about the numbers or a contribution to the decimal system from India. A short description of contribution to decimal system from India. Now let us come to something else. When we contributed these numbers or decimal systems, these were traveling, the knowledge traveled from India to West via Arab or via China. These are the 2 routes through which knowledge got transmitted from India to West. In the West, they were following the Roman system, Roman numeric system. So I, X, IV, etc. But if you take those numbers, when there was trade, these Indian traders, they used to calculate very fast, because if you multiply, suppose 328 with 46, multiply that using decimal system and try to multiply that using Roman numerical system. Decimal systems, within 5 minutes you will complete the multiplication. Roman numerical system, it will take the complete day to do that. So these travelers were very fast. So in the West, they were astonished and they were ultimately forced to accept the Indian numeral system. But that went through the Arabs, and they were in direct contact with Arabs, so they called it Arabic number system. Or later, nowadays, they call it Indo-Arabic number system. But when they adopted that, there was a problem. The problem was they were using the numbers which are countable. 1, 2, 3, 4, etc. You can count them. But in the Indian number system, there is 0. 0 is not countable. You cannot count it. There was infinity. You cannot count it. So it was difficult. They thought that these 0 and infinity, these are the numbers from Satan. So they were rejecting. So but ultimately they have to accept it because the number system or counting or calculation became easy. They have to accept it. But still there was a problem with the negative numbers. Although they accepted 0 and etc., there was a problem with the negative numbers. This I will skip. Number and numeral we have already discussed. The only thing is there is a directional value to the number, which is you have a reference at 0. If you move to the right of reference, you get positive numbers. If you move to the left of reference, you get negative number. This was not acceptable. This negative number was initially not acceptable, even if in the period of Renaissance. Next. Now let us consider two scientists, Arnold and Pascal, and they considered the negative number. So in the negative number, we know 1 is greater than minus 1. Present number system, we know 1 is greater than minus 1. Next. So if I divide 1 by minus 1 by 1 and 1 by minus 1, I will get minus 1. 1 by minus 1 by 1 is minus 1. 1 by minus 1 is minus 1. But minus 1 is a smaller number, 1 is a larger number. So minus 1 by 1 is a division of a smaller number by larger number. 1 by minus 1 is the division of larger number by smaller number. They cannot be equal. Division of smaller number by larger number is a small quantity. Larger number by smaller number is a large quantity. How can they be equal? But now they are equal. 1 by minus 1 by 1 is equal to 1 by minus 1. They are equal. This was not acceptable. Logically, this is not acceptable. So they said that accepting negative number, it is a paradox. It is difficult to accept the negative number. Initial. Next. But Leibniz, he said that the margin of error is too narrow to solve this paradox. This paradox because 1 minus 1, they are working numbers. You can use them actually and get proper answer. So even if this is existing, it is very small. This is a paradox which cannot be solved. Next came Euler. Euler said that let us take a number a which is greater than 0. Any number a greater than 0. Then we divide by larger number. So a by 1000, that is less than a by 100. So that way you go reduce the denominator up to 0. If you reduce the denominator up to 0, a by 0 is infinity. Okay, so then what we are doing is 1000, 100, dividing it by 1000, 100, 50, 10, 2 and 0. So gradually these numbers are decreasing. Smaller number, dividing it by smaller number. Smallest is 0, you get infinity. Now if you go to a smaller number than 0, minus 2 is a number which is smaller than 0. So a by minus 2 should be greater than a by 0. That should be greater than infinity. That is not happening. A by minus 2 is minus a by 2. It is not greater than infinity because beyond infinity there is nothing. So Euler gave this argument and said that it is difficult to accept the negative number because it does not address this issue. So to address this issue, later mathematicians in the Renaissance period, they came up with different types of numbers, integers, reals, complex, etc. And each set of number has a set of rules, and there were overlapping of these rules. With that, they accepted 0, infinity, and negative numbers. Next. Now comes the question, why negative into negative will be positive? It should be negative into negative should be negative. Why it is positive? Let us look at this from the point of distribution law, law of distribution. A into B plus C is AB plus AC, that we know. This is law of distribution. Now consider negative into negative as negative. If we do that, minus 2 into minus 4 plus 3, that will be minus 2 into minus 4 plus minus 2 into 3. That will be minus 8 minus 2 into minus 4, because negative into negative we are considering negative, so that will be minus 8 into minus 6. On the left hand side we have minus 2 into minus 1. So minus 2 into minus 1 will be minus 2, because minus into minus is minus. Then minus 8 minus 6 will be minus 14. So it will be minus 2 will be minus 14. Therefore, negative into negative cannot be negative. If you consider it to be positive, next, you will get 2 is equal to 2. On both sides, you will get 2. So this was the logic for minus into minus is equal to plus. Now, this all these required a large number of abstract mathematics. In case of Bharatavash, there was no abstraction. It basically depended on the philosophy. So we considered the philosophy of what is zero, what is negative, what is positive. This is encoded or coded in Brahma Sutta Siddhanta by Brahmagupta. This Brahma Sutta Siddhanta contains what is integers, what is arithmetic operation, and different other mathematical principles. Next. Now, to know about negative and positive in the Bharatavash, we use this system that Sun is at the epicenter of an ellipse and other planets are rotating in an elliptical orbit around Sun. This was given by, as we know, Kepler in 1609 current era. Kepler gave this. But before Kepler, much before Kepler, many scriptures in Bharata, astronomy, like Surya Siddhanta, Aryabhatiya, Brahma Sutta, Siddhanta, etc., they defined elliptical orbits of planetary motion and with mathematics, required mathematics behind the different stages of planetary motion. For example, next, this is a sloka in Surya Siddhanta. The meaning of this sloka is when the planets are pulled strongly by Sun at their Uchchasthana, which is the apices, they will have highest orbital velocity. This is called dhanam. And when they move away from velocity, away from that position, their velocity will decrease. That is called runam. So they had the concept of dhanam and runam. Next. Based on that, they classified the numbers. Philosophically, they classified the numbers as dhanam, which means wealth or accumulation or credit. Now we call it positive number. Then Shunyam, which is void or empty or this table state which we call zero nowadays. And Runam, which means to return, how much you have to return or what is the depletion or what is the debt, which we call the negative number. So according to Brahmagupta, positive or Ranang and negative, these are transient states with respect to zero or Shunya. Shunya is the stable state. With respect to Shunya, if it is increasing, it is Dhana. If it is decreasing, it is Runa, which means if it is increasing, it is positive. If it is decreasing, it is negative. Next. So this was the philosophical explanation of positives and negatives. So they will never go below zero. Zero is the reference. So beyond zero, they will increase or they will go away from zero or come towards zero. From Shunya is the stable state. When they come to the Shunya, they will be stable. Next. He gave the rules of addition, rules of subtraction. I am not going to read out the rules. He encoded this or coded this in his Brahma Supta Siddhanta, rules of multiplication, and in the rules of multiplication, you can see 0 into 0 is 0. Finally, next, rules of division, last one you see, Khong indefinite, how 0 divided by 0 will be 0. For that, you see, he is not using Shunya, he is using Khong. Khong, Kha means, in Odia we call Khaga. Khaga means that creature which travels in Kha. Kha is sky. Khaga is a bird. So sky, Khong is sky. So sky divided by sky is sky. Or void divided by void is void. It is not zero. He's not talking about zero here. Zero he talks later if you divide, or particularly Aryavata talks about infinity as Ananta. When you divide anything, any number by zero, you get Ananta. Next. So that is all about the number system, decimal number system, and the algebra. That was the contribution from India. Next, we'll look at the hidden treasure in India, which is particularly applicable in electronics. So this will be interesting for electronic students, particularly digital electronic students. Professor Sahu had seen a part of this and he had some questions. Today I will be able to answer those questions, hopefully. This is our knowledge system, complete knowledge system of ancient Bharat is this. It starts with Shiva Sutras, then goes to 4 Vedas, then that is complemented by 6 Vedangas. In the Vedangas, 6 Vedangas, there is one Vedanga which is called Chandas. What is Chandas? As we saw up to now from the Indian scriptures, everything is described in the form of a shloka or hymn. So shloka has a particular pattern. In a particular pattern, it is written. The manner or the pattern in which you write the shloka is called chanda. Chandas describe that pattern or way of writing a shloka. As you know, we have for writing a shloka, you start with a syllable. Syllables will form words. Words will form lines. And lines will form your hymns or shloka or the poem. Next. Let us look at this shloka from Adi Shankaracharya. Na punyang na papam, na saukhyang na dukkhang, na mantro na tirthang, na veda na yajna, ahang bhojanam, naiva bhajyam, na bhakta, chidambara rupa, shivoham, shivoham. Now if you look at this, when you pronounce this, now you pronounce it for a small time. Punyam has a pronunciation of for a larger thing. You require more time to pronounce punyam. Similarly, papam you require more period, saukhyam you require more period. So there is a pattern. Small, large, small, large, small, large. There is a pattern. Next. So if you classify syllables, then we have short pronunciation, which are called laghu, and long pronunciations, which are called guruj. So we have laghu and guru, two types of syllables. We classify them. Some syllables you require short time to pronounce. Some syllables we require long time to pronounce. Like a, aswai, these are all short pronunciations. Laghu. A, dirghai, e, these are all guru. They require long pronunciations. Next. Based on this pronunciation and combination of these laghus and gurus, we require combinatorial algorithm. There are 6 pratyas or 6 algorithms in Chanda Shastra for this. These are Prastara, Sankhya, Nasta, Udishta, Lagakriya, and Adha Yoga. I will describe uh, five of these. The last one we will skip, but the rest five I will describe now. Next. Chanda Shastra is a prosody. Next. Now that has Prastara, the first algorithm is called Prastara. Prastara means expansion or the procedure to lay out all possible metrical patterns with a given number of syllables as an array. Metrical patterns means arrangements of logos and gurus. So this Prastara starts with this. So there are two types of syllables we have discussed. What are these syllables? Guru and Lagu. G and L types of syllables. Next, mix them. These two syllables, so G and L, mix them. So what you will do is take G and L, below that again write G and L, and on the right hand side write G and L. So mix now them. So if you mix them G, that gives you GG, LG gives you LG, GL gives you GL, LL gives you LL. So mixing them you will get this. Continue this way next. So mix them themselves again. So GG, GL, LL, repeat that, continue the mixing process. You will get GGG, LGG, GLG, LLG, etc. So you will get 8 patterns. Now you will get 8 patterns. So this way you can keep on increasing. So we started with 2 syllables, then we went to 4, now we have got to 8, then you can go to 16, etc. Next. There is another rule for this Prastara. This I showed you one Prastara. There is another rule that was from the Chanda Shastra. This is from the Brutaratnakaram, 6th chapter 2 to 3. Sloka. So what you will do is start with a row containing G. So let us consider LLG. So this is a row which has G in this. Next. Identify the first G from the left. So from the left in the third position we have G. Place L below it. So below G we will place L. Then we will bring down the elements to its right. So beyond right, beyond G there is nothing. Right to G there is nothing. So we will not bring down anything. So we have L. We have written L below G. Beyond that L there is nothing. So L remains as it is. Then on the left we have 2 positions. So there those positions will be filled by G. So fill them by G. Now again go from left. So first in the first element you get G. Next. So put L below G. Then bring down the next 2. So GL comes down. Then in the next second position we have G. So below that GL. And right side will be brought down. Left side will be G. Then first position is G, so that will be L. Next two will be L. When you get all the L's, then you stop. So this is how you will proceed. This is another rule for the Prastara or expansion of LG. So I have taken it for 3 numbers. You can take n number of this 4, 5, 2, anything you want. But this is how you can go proceed. Next. Then comes the Sankhya. Sankhya is the process of finding total number of metrical patterns. That is total number of rows in the Prastara. If you do the Prastara, how many patterns you will get. Which means if you have got n syllables, then how many words you can form from those n syllables. For that, Chanda Shastra gives an algorithm. Start with n syllables, half the number n divided by 2 and mark it 2. If n cannot be divided by 2, deduct 1 and mark 0. Proceed in this way till you reach 0. Then you start with 1 and scan the sequence marks from the end. If you get a 0, multiply by 2. If you get a 2, square it. For example, suppose we have a 6 syllable meter, n is equal to 6. 6 by 3 is 3 mark 2. Now 3 cannot be divided by 2, so 3 minus 1, that is 2 and mark 0. Now 2 by 2 is 1, so mark 2. 1 minus 1 is 0, so mark 0. So now you have reached the end 0. So now the sequence is 2, 0, 2, 0. So sequence is 2, 0, 2, 0. Now you will multiply by 2 or square 2. So that is 1 into 2 into 1 into 2 square, and that into 1 into 2 square, that into 2 into 1 into 2 square into 2 square, that is 2 to the power 6. So if you have a 6 syllable number, you will generate, or if you have 6 syllables, you can generate 2 to the power 6 types of metrical patterns. Next. So on the application is this, we are taking 3 syllables. So in the 3 syllables, the pattern is this, the sequence is given in the left side. You construct a word. I am going from the bottom. LLL, 3 lagos, so Sagara. Then GLL is Sagara. LGL, Kobato, you can form this way. GGL, Akasa. Total number of words is 2 to the power n. This number of, you can see there are 8. So here there is 3, n is 3, total pattern is 2 to the power 3, which is 8. Here you can see there are 8 patterns possible. And 8 words you can form using combination of Raghu and Guru. Next. Now we'll continue with that process of finding the numbers. Suppose you have a Sankhya SR for R is equal to 1 to n. So for that, the Shloka Sutra is this, and the meaning of this Sutra is that if you add them S1, S2, etc., you will get 2Sn minus 1. Next. The next Sutra, Paripurnam, that gives you, if you have Sn plus 1, that is equal to 2 times Sn. If you add these two, next, that gives Sn is equal to 2 to the power n, which is the number of total number that you can form, total number of patterns. And if you add them, that gives you ultimately 1 plus 2 square up to 2 to the power n is equal to 2 to the power n plus 1 minus 1, which is definitely, you can recognize from this that this is the formula for the geometric series. Next. So a formula for the sum of geometric series. Next. Now, what are the types of meter? This is not required, but let me give you. There are 3 types: Samavartas, Ardha Samavartas, and Visamavartas. Samavartas, meters which have same pattern in all 4 padas or patterns. Ardha Sama, meters which are not same but whose halves are same. Visama, which are neither same nor Ardha Sama. Next. Now, what is the number of vratas? We have the 2 to the power n is for samavratas. Now, if you have Ardha samavratas, it will be 2 to the power n 2, that squared minus 2 to the power 2. And if you have Visamavratas, this will be 2 to the power n squared minus 2 to the power n whole square minus 2 to the power n square minus 2 to the power n. So these are the numbers of meters that you can, metrical patterns that you can form in Samavrata, Ardha Samavrata, and Visamavrata. This is not important. This is particularly important for poetic formulation. Then comes the Nashta. If a row number is given, what is the pattern, metrical pattern in the Prastara? If the row number is given, what is the metrical pattern? That is given by Nashta. So this is an algorithm to find the metrical pattern. What you will do is start with the row number, then have it, if possible, and write an L. If it cannot be had, add 1 and have it, write a G. Proceed in the same manner till you find the metric. So let us find the 7th metrical pattern for a 4-syllable prasthana. 7th row. So in the 7th row, what will be there in a 4-syllable prasthana? So what we will do, 7 is not possible to have it. So divide by 2, it is not possible. So add 1. 7 plus 1 by 2 is 4. So write G. Then 4 by 2 is equal to 2. So write L after G. So GL. Then 2 by 2 is equal to 1. So write another L. So GLL, then 1 is not divisible by 2, so add 1 to that by 2, that is 1. So GLLG. Now here you will stop because you have a 4 syllable pattern, you have got 4 syllables GLLG. Now, whether this is correct or wrong, how to verify that? Put G is equal to 0, L is equal to 1, then you can see that this procedure leads to the desired metric via the binary expansion. 7 is equal to 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2. For L, we are putting 1. For G, we are putting 0 and proceeding this way. That gives you 2 to the power 1 plus 2 to the power 2. So that gives you this number 7. Next. Then find the row number. This is the opposite of that. Find the row number in Prospero for any given metrical pattern. So pattern is given, find out what will be the row number. So the algorithm is start with the number 1, scan pattern from the right, beginning with the first L from the right, double it when L is encountered, double and reduce by 1 when G is encountered. So GLLG, that is the 4 syllable Pastara, start with 1. Skip G because you have to go to the first L. So skip G, go to L, get 1 into 2, that is 2, then find L. So that is 2 into 2, that is 4. Next L is, so there you get 4. Finally, we have G, so that is to be excluded. So 4 into 2 minus 1, that gives you 7. So 7th row. Next. Then here is another form of Udishta, finding the row number from Prostara. This is by Dhutaratnakara, not the Chandasastra, but this is given by Dhutaratnakara. The sloka is given on the left side. It says that place 1 on the top of leftmost syllable for the given numerical pattern. Double it at each step while moving to right. Sum the numbers above L and add 1 to get the row number. So suppose we have G, L, L, G, L, L. So above G, first G is 1, then L is 2, then L above that, write 2 to the power 2, which is 4. Then next G, above that 2 to the power 3, which is 8. Then L, 2 to the power 4, which is 16. Last L is at the fifth place, 2 to the power 5, which is 32. Now above L you have 2, 4, 16 and 32. So add them, 2 plus 4 plus 16 plus 32. Then add to that, that will give you the binary number. Add to that plus 1, that will give the row number. What is binary number, what is row number, that we will see later. So that gives you the row number. Now, if I put 0 for GL, for 1 for L, I get this GL, LGLL pattern as 0, 1, 1, 0, 1, 1. Take its mirror reflection, that gives you the binary number 1, 1, 0, 1, 1, 0. That its equivalent, you find out what is its decimal equivalent, you will get the row number. Decimal equivalent plus 1. That will give you the row number. So from this, what we see, that Nasta and Udishta process, they say that every natural number has a unique binary representation. It can be represented uniquely by as a sum of different sankhyas or the powers of 2 to the power n. Next. So with that, I come to the binary number system in India, in Bharatavarsha. So for G, I write 0. For L, I write 1. On the left hand side, complete left in the green, I give the row number. Row number starts from first row to eighth row. On the right hand side, if I take G and L, G 0, L is 1, what we get is equivalent of G, G, G 0, 0, 0, L, G, G is 1, 0, 0. If I take its mirror reflection, that gives me 0, 0, 0, 0, 0, 1, 0, 1, 0, etc., which is a binary table, and it corresponds to binary numbers 0, 1, corresponds to decimal numbers. Binary numbers are on the left side. So 0, 0, 0, 0, 0, 1, 0, 1, 0, these are binary numbers. They correspond to decimal numbers 0, 1, 2, 3, up to 7. So this is the difference. The decimal number or the binary to corresponding binary number and the row number. Row number is 1, decimal number is 0. So row number is 1 more than the decimal number. This is world's oldest recorded binary system. This is given in the Chandasastra, chapter 8, verse 20 to 22. And this was another contribution which was or which went unnoticed worldwide till now. Now, of course, people have started to know this next. Now, binary system was given by Leibniz, Gottfried Leibniz, in 1646 to 1716. He was a German mathematician. He proposed this. He is also known as father of calculus and binary number system. Along with Newton, he is also credited with calculus, but that all credit is also not correct because before then, calculus was invented in Bharatavarsha by Madhava. Forget that. And that is not, calculus is not our discussion today. Now, he, Leibniz, acknowledges Madhav, but before him, Pingala gave this Chandasastra or codified the Chandasastra. Chandas were existing earlier than that, but Pingala in the second century or second century BC, so much before Leibniz, he codified this into Chandasastra, but he was not acknowledged. No mention of Pingala, but at that time, say around 1646, 17, so 17th century, there was spice tradition between India and Europe. It is possible that this knowledge was also transmitted from India to Europe. Some other time I can discuss how this has transmitted. Then we will discuss about finding the numbers, which is called the Logikriya. Next algorithm, which is a very brief sutra, very short sutra. This was expanded, this is in Chandasastra, a very short sutra, but this was expanded as Meru Prastara by Horai later, which gives the basic rules of construction of a table of numbers. Next. Can I take 10 more minutes, 10 minutes to 15 minutes?
Yes, sir. Yes, sir. Sir.
Okay, thank you. So if you expand that, this is the rule. That sutra, if I translate it into English, it says that in the first stage cell, it will hold the number 1. So you can see in the top, we have hold number 1. From there on, the following is the way to grow, how it will expand. Prastara, Meru will prastara from that point. So how it will prastara or how it will grow is like this. In the next two cells, you will put a pair of ones. So 1 and 1. Then in the third cell, the extreme cells will be 1. The middle cell, whatever is the number above that, they will be added and put in the middle cell. So in the middle cell above that, there are two numbers 1 and 1. So add them, that will be 2. Continue in this manner. So the next row will be end, both the ends will be 1. Then the next cell above that is 1 plus 2, so that is 3. Next cell above that is 2 plus 1, that is 3. Then 1. So this way you will keep on increasing. Prosperities you will keep on increasing. Next. So that is what we see in today's Mahameru Yantra or Sri Yantra, which has spiritual nature. So I will expand, I will skip that. But this is the Meru's Prastara up to 6 levels. So from 0th level to 6th level, I have taken the Meru Prastara. These will be the numbers. You can fill up these numbers yourself. Next. Now, what is the purpose or what is the use of this? If suppose you take 6 syllables, then in how many ways you can get 2 gurus from this, or 2 lagus from this, or 3 gurus, or 4 gurus? That is the question. So that is given. That answer comes from this. Basically, this is a combinatorial algorithm, or what you say. This is the recognition of the pattern. You recognize this type of pattern will be there. So pattern recognition in a very crude manner. The pattern recognition is this. So there will be 2 to the power n possibilities of all constructions. If you have 6 syllables, then there will be 64 total combinations that you can see. Irrespective of the number of gurus or lagus, the word with 6 syllables can be written in 64 ways, because for 6 syllables there will be 64 combinations. Specifically, if you take 2 gurus and 4 lagus, what you will do is come from the row 0 to come row 6. At the sixth row, the first one, which is the leftmost, that gives you all gurus. Second one gives you 1 guru and 5 lagus. The third one, which is 15, gives you 2 gurus and 4 lagus. Fourth one will be 3 gurus and 3 lagus. Sixth will be 4 gurus, 3 lagus, which is repetition. Then and 2 gurus, then all gurus. So this is how it will be. Next. So this was the purpose. Now, if you look at that, the Meru Prasthana, and if you look at today's Pascal triangle, the Pascal triangle is actually a rotated version of the, or Meru Varna is a rotated version of the Pascal triangle, or Pascal triangle is a rotated version of the Meru Varna or Meru Prasthana. So Pascal triangle is not new. It was also given by the Chandasatra in the earlier days by Pingala. Next. Now from the Meru Prasthana, you will get another thing, another very important thing, which is called Fibonacci series. So if you add the corners, that gives you the Fibonacci series. The Fibonacci series, why it is famous? Because the numbers are in golden ratio. 1 is to 1.618 ratio. Next. Where it is applicable, this is applicable in many things, genome sequencing, design of antenna, in the seeds of the sunflower. So maximizing this is an optimization technique. So many where you will find the Fibonacci series of Fibonacci numbers. Next. Now, to be fortunate and to give credit to Fibonacci, he has mentioned that he got this from, this is the Indian method and he has got it from India. He acknowledged the Indian way of mathematics and Hindu numeral systems or Indian numeral systems in the Europe. For the first time, he acknowledged it, Fibonacci. So that credit should be given to him. Others have not acknowledged this. What was the contribution of India? That was not acknowledged. And our people said India had no contribution, or Bharat had no contribution. We have seen many contributions up to now, which are applicable to the fields of electronics. Next. Now, from Meru Prasthana to Pascal triangle, how it has happened. Pingala in around 200 BC, he gave it in India. Then in the 11th century, it was Omar Khayyam in Persia or modern day Iran. It went there. From there, in the 13th century, it went to China by Yang Hui. Then in the 16th century, it went to Europe, Niccolo Tartaglia in Italy, and Blaise Pascal in France. Uh, Next. Now, this Chanda Shastra, it's developed, basically it was codified by Pingala, but after that it has continued to develop till 1550 current era by Narayana Bhatta, where he gives in the Narayani commentary on Vritaratnakaram that I showed you, or 2 stanzas from Vritaratnakaram I have shown you. Others are there. I am not going to discuss this, but there has been a continuous uh, uh, discussion or continuity in the Chanda Shastra in India. But after 1550, because of the colonization, this has gone down. This was extinguished gradually. Next. These are some of the important references from Chanda Shastra. So I come to the end of Chanda Shastra. Next. Then finally, to the last leg is pi to pi. Pi is important in science, including electronics, definitely. Now, in India or in the Bharatvarsh, there was something called Sulba Sutra. In the Sulba Sutra, they mentioned that pi, they never mentioned pi. By the name pi, they never mentioned. They say the ratio of the perimeter or porini to the diameter or measure is 3. This is a very crude approximation to pi in the pseudo sutras. Without using pi, Aryabhatta said that you can find out the circle area as half into the circumference into radius. So half into Paridhi into Vyasa gives you the area of the circle. So that was given by Aryabhatta. Then he found out pi. Next. So in his Aryabhatya, he finds pi as 3.1416. This is the slope by which he finds the ratio of the perimeter to the diameter by this 62832 by 20,000. That gives you this number 3.1416. So I'm not saying that pi was invented in India. It was independently invented in India as well as in West, particularly in Greece. Next, we should give credit to the Western people also where they deserve the credit, but we should also get the credit when we deserve the credit. Their credit also we should get. Then the next was by Madhava. He gave a series, infinite series, pi is equal to 4 into 1 minus 1 by 3 plus 1 by 3 minus 1 by 7 plus 1 by 9, etc. So they go up to infinity. He gave an infinity series for the first time. Madhava gave an infinity series, which is basically an integration by part, so calculus. This was the stepping stone for fundamental of calculus. And Jyotisha or astronomy in Bharatvarsh is the root of calculus. This was reinvented by Gottfried Leibniz in 17th century. So this series also is called Madhava Gregory series, although it should have been called Madhava series and Gregory series separately. Or now they are calling it. Usually we know this as the Gregory series. Now people are recognizing it as Madhava Gregory series. Earlier it was not Madhava Gregory series. Next. Then in India, which is in the modern India, pi was given by Srinivasa Ramanujan. So this is the formula. This was at that time when he proposed this formula. This was the fastest method or fastest formula for calculating pi up to an infinity series as an infinity series. Fastest method existing, fastest algorithm. Next. Then we know these two people. Left side is Marconi, 1897. He invented radio, and he is credited with invention of radio. But in 1895, Sir J.C. Bose has demonstrated the working of radio. Now he is getting the credit. Earlier it was only Marconi. Now Sir J.C. Bose is also getting the credit. Now, Marconi used meter waves. Sir J.C. Bose used millimeter waves. Sir J.C. Bose used horn antenna, not Marconi. Marconi used a normal dipole antenna. Sir J.C. Bose used horn antenna for the first time. First the design of horn antenna was by Sir J.C. Bose. So those are many things are to be credited to Sir J.C. Bose, but the credit goes to Marconi. Next. Then another contribution is Raman effect by Sir C.V. Raman in India. Next. Then this is what we know. Who invented aeroplane? Wright brothers in 1903. They invented aeroplane. We don't know anything about the contribution from Bharat. Next. Sivkar Bapuji Talpade. 8 years before Wright brothers in Bombay, he flew an aircraft or a machine for more than 300 meters. He designed it and flew it for more than 300 meters. It was an unmanned air vehicle. So UAV for the first time in Bombay 8 years before Wright brothers he did it under the guidance of next Pandit Subbarai Sastri by following the book. Book I'll tell you. And he called this machine as Maruschaka, the flying machine. You can see the machine figures here by following a book called Vaimanika Shastra. Vaimanika Shastra is written by Maharshi Bharadwaj, and it describes in this Vaimanika Shastra, it describes different types of aeroplanes or different types of bimanas. It discusses about bimanas, so it describes different types of bimanas. Now, this is a controversial book. Next. Vaimanika Shastra is a very controversial book. A pilot, Anand J. Bodas, he says that there is a reference to ancient aviation in Rigveda by Maharishi Bharadwaja, and in Ramayana definitely we have seen this Puspaka Viman. So to Vimana there are references, and fabrication or the technology of Vimana was existing and was given by Maharishi Bharadwaj. That is what Anand J. Bodas says. But Professor Ankit Sule of TIFR, he says the issue is not a question about expertise in the Vaimanika Shastra. The claims about Vaimanika Shastra that were made at the event are based on school level physics and other basic science. These are not principles of astronautics or astronomy. So that is the opinion of Professor Ankit Sule from TIFR. An American scientist, Travis St. Taylor, he has designed a vehicle, air vehicle, and experimented it. And the experiment he performed was purely scientific, and the shape he made was using the information from those texts in a viable, and he says that the shapes are a viable aerodynamic structure. Now, I do not claim here, we should not claim that the aeroplane technology was invented or was given by India, but these are different opinions that we can see next. Now, why I say, or why we can say that the knowledge from Bharat, ancient Bharat, has traveled to West. What could be the root? You know, the Panchatantra is a Sanskrit text that was around 500 BC in India. Then it went to Persia, written in Pallavi language, same time around 500 CE. Then Arab, so Arabic, Saudi Arabia 750, Greek in 1080 current era, then Spain 1250 current era, UK 1570 current era. So this way it went up to Germany. So this shows the route in which knowledge from India traveled far off up to the Europe. So there it is possible that the knowledge that was developed in India has gone to Europe. It is not the other way that now we relearn those knowledge from Europe. Next. Finally, let me conclude with a sloka because we are considering Bharat. So in Bharat, there are two itihasas, Ramayana and Mahabharata, by on Rama, other is about Krishna. So let me conclude with a sloka on Krishna. O Krishna, the fortune of gopis, the destroyer of demon Madhu, the protector of cattle, the one who ventured the ocean depths, destroyer of evil doers, one with plow on the shoulder, and the bearer of nectar, may you protect us. So this is the sloka. Now, in this sloka, if you look at this from the outside, you get this meaning. Now, use the number system, Kattapayadi number system. Kattapayadi number system is what do you do is every number is assigned to a syllable. So if we decode this The syllables convert the syllables to the numbers. This Roko gives you the number 3.14159265358979323824633832792. It has only one mistake in pi. In between, it has only one, at one place there is a mistake. This 2, 3, that should be one thing. If you consider today's calculation of pi. So this is the demonstration of cryptography that also existed in India. So with that, let me come to the saying of Albert Einstein, we owe a lot to Indians who taught us how to count through the decimal systems, without which no worthwhile scientific discovery could have been made. Thank you for your participation. And now I rest. If you have any comments or any questions, I will be happy to address them.
Yes, sir.
Yeah.
Professor Basu.
Yeah, first of all, I offer my heartiest congratulations for this amazing lecture. In fact, I didn't know many of the things, and so it's just like a student of ancient India. Well, it's really illuminating. Now, my first question is, well, this is a nice lecture, but have you made any publication out of this contents?
No, sir. No,
Why
not yet.
not? Why not? Yeah, this is
No,
very curious to know.
sir,
It
sir.
should be. It
I,
should
I,
be.
I'll tell you. You know, I made an accident. I
Huh.
cannot write.
Oh,
My
I
hands
see.
are not working. What I do is I ask my daughter when she has free time, she
Hmm.
prepares these slides for me. So that
Hmm.
much time I get from her.
Hmm.
So I put it in the form of slides. I cannot
Hmm.
write. That is the problem.
Oh, that's
Only
the
my
trouble.
mouth is working, head and mouth. These are the two things which are working.
I see.
I could not do that.
Because I think even you can write a book or write a series of articles claiming that. And well, uh, it should be made known to the Western world. I mean, this is my opinion.
Sir, then,
Well, the
then
first one you mentioned that contribution, Indian contribution is zero. I mean,
sir,
that is symbol zero, and Indian contribution to science is zero. But
sir,
this stalwarts like Leibniz and Pascal, not Pascal, they acknowledge this Pingala Shastra and all that. So that is to be made known. And Indian numeral system is now called Arabic numeral system. And
yes,
I
sir.
feel, well, really, I would say when in downcast, when they call this, in Word, Microsoft Word, you find Arabic numerals.
Arabic,
Well,
yes.
what is happening? This is Indian. Okay,
This
and
one,
many few questions related to your art, the presentation is
sir,
in Pingala, right? Pingala is
yes,
you mentioned division. Positive by positive is positive, negative by negative is negative, but
sir.
positive by negative that was not mentioned, or negative by positive it should be negative. That
That
was
is
not mentioned.
negative. That is negative. Yes, in his sutras he has not given that. Whatever he
Uh,
has given in his sutra, that I have mentioned.
oh, I
Actually,
see.
I
I see.
have taken it
That
from
is
his
that
sutra.
is missing. Well, and about that thing, mm, this aeroplane, which was
Sir,
fabricated in India before
sir.
8 years before Wright brothers, I think that has been reported by something.
Yes,
And even as far as I remember, there was one. Is it connected to aeroplane? A Hindi cinema, and that in this, I don't remember that name. That has been, but unfortunately, people do not pay any attention to that
right.
discovery. Well,
Sure.
okay. So aeroplane and Valmiki and Ramayana is we have heard about Vimanos and everything, and now they call this I mean wishful thinking and all that.
Yes.
Okay, I appreciate that even if it was not fabricated, but it was some kind of concept
Yes.
out of which this Vaimanic Shastra was developed.
Yes, sir.
Similarly, I had a curiosity, in 6th century or 7th century, if you go to say Angkor Wat or this Cambodia and those parts, Indonesia, Bali and all that,
Sure.
you have different temples. For example, Angkor Wat or what is that? I remember Borobudur. These
Sure.
things they depict, I mean, events in Ramayana.
Yes.
So
Yes.
Indian must have migrated from different ports of
Sure.
India to these places.
This
So
is
oceanography and ocean science was really developed. I mean, it's very easy to conclude. So
sure.
are you? What I want to know that is there any recorded version or a recorded knowledge which is available, and has anybody worked on that?
Not on aviation, but about the Cholo dynasty,
Hmm.
they have gone up to Bali, Indonesia. That is available.
Hmm.
I had made the presentation earlier
Hmm.
on that.
Hmm.
There is a temple called Bagreswaram Temple.
Hmm. Hmm.
The
Brihadeeshwaram temple. Huh?
yes, so about
Hmm.
that, its replica is in Bali.
I
So
see.
Mahasivaratri, why we follow Mahasivaratri? On
Hmm.
that, I have made a presentation in Odia, short
Hmm.
presentation.
Hmm.
There, it is there. It is there, available there. So
Hmm.
they have expanded. Cholo dynasty expanded up to Indonesia.
Hmm.
Beyond Indonesia, but Indonesia, these remainings are there. Although
Hmm.
it is a Muslim country, they also celebrate Mahasivaratri even today.
Yeah. Garuda Airlines, and then
Yes,
Saraswati.
yes.
Saraswati is there, is in their currency. Yeah,
Currency,
that's.
Ganesh is
Yeah,
in their currency.
yeah.
So they,
And
they
one more question is Pingala. You mentioned 1200 C, isn't it?
mm,
As far as
sir, that is controversial. Why? Uh, because uh, because of the church influence,
yeah,
they have restricted any invention or anything to
yeah,
humankind
yeah,
to be below or after 3000 BC.
hmm,
But actually, these are much before 3000 BC.
hmm,
So the history that we get is
hmm,
the history written by Westerners.
hmm,
We have forgotten our history. If you look at Ramayana
hmm,
or even in the Mahabharata, if you look at the astronomical positions of the planets,
hmm,
there are about more than 600 evidences in Mahabharata which says that it occurred in 15,000 or before 15,000 BCE.
hmm.
But that is not acceptable to West because of the church, nothing has come before God created man in 3000 BC.
That's true.
So these the numbers that I saw, these are all controversial. I do not accept that, but those are mentioned in the Western by the Western people, and those are those have been accepted everywhere. So we have to accept that. We are forced to accept that, but it is much before that, because Pingala has written Chanda Shastra.
Hmm.
Chandas existed in Vedic period, in Ramayana period. So it must be before the Vedic period or Ramayana period. So it must be at least 15,000 years old. But they say that it is 300 BCE. So we are accepting that 300 BCE or 1200 BCE, that whatever it is.
And one more question. Is
Yes,
there any recognized scientist or recognized mathematician
sure.
beyond Aryabhatta and Brahmagupta?
Yes, Ramanujam.
No, Ramanujam, in British India.
Yes.
So
Oh,
I'm
before
not talking
before
about
British India. Yes,
that.
Bhaskaracha.
After
Bhaskaracha.
Brahmagupta.
Bhaskaracharya, Madhava. So these are the
Madhava. Yes, yes,
Madhava,
yes. And
Bhaskaracharya.
of course, this
Nirakanto,
Sawai Mansingh in Jaipur.
Jaipur, right?
Yeah, yeah, in Mughal during this Mughal period. Yeah,
Mughal period. Yeah.
yeah. Okay, okay. I, I am very curious and I wanted to talk and discuss many things, but I am taking much of the time. So you please, somebody else, please come forward and ask questions. Thank you very
Thank you,
much.
sir.
Thank you very much.
Thank you, sir, for listening. Thank you for being there.
Any other question by the students? Naran?
I have one more comment because I
Sir,
didn't know that Professor Mishra is now well handicapped. I would say, as he had said, I didn't know that. But uh, is there any way that Barampur University can help him, giving a helping hand, say a an assistant to write down? He will dictate, he will write down, and he will provide his slides are available, and the figures will be there to write these things and at least publish something, and then it disseminates to the outer world. I think you should think about it.
Yes, it's a good suggestion. Actually, the university should.
No, I had, presently, well, I started it, I realized it that, well, not realized, I submitted in a group a proposal to Indian National Science Academy History of Science. Now, that was awarded. We got it in 2011, I would say, 2010 or 2011. But the principal investigator, unfortunately, I was not a principal investigator, so well, when it's completely wasted, we couldn't utilize. Only recently, last year, I submitted a project to Indian National Science Academy with very restricted area, history of semiconductor research in India. I got that award, and now it's 8 months. I am going to present next month in May. Usually, they invite proposals, and you have to submit before 31st of December each year. So that is over, but that is a very good way to get support and get funds. So this is for your information. I
thank you,
think,
sir. Maybe the department can do something.
yeah, please. As his co-investigator, he will be the principal investigator. Somebody will take the responsibility of co-investigator and this. But it's already, but you have to wait for 6 more months and try to find out other sources which can
Sir,
support,
yes, sir.
give
Yes,
some funding.
sir.
Okay, I am in touch with Professor Sahu and Narayan Sahu. Well, if I find
Sir,
something, then I will definitely give you some more positive information where to
sir.
get support.
Oh, thank you, sir.
Thank you, sir. Thank you, sir.
Naran.
Uh,
Any other?
Sir, some of our students they will ask some questions.
Yeah.
Okay. Yes.
Some students side. Yes. Sorry. Madhu,
Is there any question? Otherwise,
sir.
uh,
But sir, actually, what Mr. Sir told or delivered uh, for us, it is totally completely new because
yes.
I hope we are maybe 95% on our about the past history or our ancestral achievements.
Hmm.
So, and truly it will inspire us because most of us always we are telling that our passion is to go USA or to culture the to adopt the foreign culture, but our Indian culture is so good or so bright that truly it will inspire us, sir. And really, thank you very much, sir.
So let us thank Professor Mishra for giving a very illuminating and new talk. Really, I also didn't know many things. I had previously his lectures, but this is something new also. So he will continue and inspire the students and give the lectures on our ancient culture and our science, jnana and vijnana, and philosophy of our Indian culture. Sir, any contest on Oriya, I mean, contribution?
Siddhanta Darpana.
Acha, okay. Siddhanta
Siddhanta Darpana.
Darpana.
And
Uh,
that is the last correction to the Surya Siddhanta.
uh,
No,
any
because of
other?
the
Sir, that
precision,
is which year, Siddhanta Darpan?
Siddhanta Darpana was
18,
in
18th century,
18th, no, 19th century. It is in 19th
or
century.
19th century.
19th century.
Uh-huh.
End of 19th century.
So, thank you, sir,
Then
for
Leelavati Sutra in mathematics is Leelavati
Lilavati
Sutra.
Lilavati Sutra is Odia, I mean, concept.
There are two Leelavati Sutras. One is by Bhaskaracharya
Uh,
for his daughter. One is by India Odisha, which is from Khurda.
uh-huh.
Many people do not know this.
Also, we heard that about this Konark temple while building, they made some architectural point. I'm just
That is
telling vaguely,
that
but
is
we
in
heard
Agama.
in. Huh?
That is in Agama. Agamas. So that is
Uh-huh.
Vedic knowledge of Agamas.
So they made the magnet and all the things. What it, how far it is? We heard that the story like that, but what is the real? I mean, thing and
No,
the
I
best.
have not worked on that.
Uh,
Maybe I will start working on that.
okay, thank you, sir. Thank you.
Thank you.
Narayan, now okay, conclude from the department. Okay, thank you, sir.
Sir, thank you, sir. Now I request Deepak sir to give vote of thanks. Deepak sir, please.
So, good afternoon, all. Uh, Now we are going to conclude the session. So, before concluding, I would like to thank our speakers as well as all the students also. First of all, I would like to thank Professor Basu for and delivering a talk related to bottleneck in photonic devices as well as current trend and what are the developments going on. So that was really a new talk for us actually. So most of the people in our department working on devices or in planar antennas and optimization as well as soft computing. So that is also one new area that students as well as teachers should know as well as focus. So again, thank you, sir. And, and next talk was really uh, interesting as well as it was also new to all of us. Uh, uh, I would like to thank Rabindra Misra sir for delivering a talk starting from Shunya to innovation. So he delivered related to zero as well as decimal number system, cryptography, uh, as well as binary number system. So that was really interesting, and most of the students uh, hardly knew all about this. So that's why it was really very interesting, sir. So every time Mr. Sir prepare a very new topic every time uh, w- with the help of his daughter. Uh, it is actually very difficult. So that's why we sometimes could not join his popular talk, but this time we completely listened to him, and we inspired from him how to present a seminar or a popular talk. So again, sir, I would like to thank. Uh, and finally, I would like to thank Professor Trinath Sahu sir to uh, chair the session. So he's also every time associated with our department. Every time we take suggestion from him. So again, sir, thank you. And finally, there are a lot of student also in online because it is a webinar. Um, Here physically students are there, as well as online also some participants are there. So again, I would like to thank all the students, as well as again, it is a webinar. It was actually proposed by our honorable vice chancellor ma'am to conduct some Indian knowledge system webinar, as well as physical or virtual mode. So it was in we were all inspired by her. So that's why again I would also like to thank patron, as well as chief patron. So again, organizing team and all the faculty member also in our department. So thank you all.
So goodbye. Nice meeting. See
Okay, sir,
you.
with this we'll all conclude the session. Thank you.
Thank
Goodbye.
you. Thank you, sir.
Thank you, sir.
Thank you. Thank you. Goodbye.